the coordinate plane with rational numbers. Again, what are rational numbers? Rational numbers are any numbers that can be written in a fraction form. It could be a whole number, an integer, a decimal. So let's look at our mystery number, our number routine. I am a fraction less than 1. So I am a fraction less than 1. So that means the numerator has to be less than the denominator. Part has to be less than the whole. In simplest form, I have a denominator of 5. So the denominator is 5 right here. So if I am a number less than 1, options could be 1/5, 2/5, 3/5, or 4/5. Could it be 5/5? No, that's 1 whole. Has to be less than 1. So good. We're good so far. I am greater than 1/3, but less than half. Well, half. Well, let's look at our choices right here. I am less than half. That is 50 hundredths, 5/10, or 50%. So if the whole is 5, what's half of that? 2.5. So it's either 1/5 or 2/5. Either one. But 1/3. Can 1/3 go into a hundredths place? No. So we're going to have to divide 1 divided by 3. So we're cutting 1 into 3 groups. Can 3 go in 1? No. So that leaves us with 1. How can I continue on adding a 0 here without changing the value of 1? 0.0. So I bring down to 0. How many 3's go into 10? 3 times, which is 9. So 10 minus 9 is 1. I add another 0 and bring it down. How many 3's go into 10? Having done this before, just like deja vu again. It goes in 3 times. You know what? This is a repeating decimal. So I'm going to put a bar notation. What number is repeating? The 3. So it is greater than 33 hundredths with a repeating bar notation, but less than half or 50 hundredths. So which of these two fractions, 1/5 or 2/5, is greater than 3300 but less? So 1/5, 2/5. Can I rewrite 1/5? I could divide it into 1 divided by 5, but tenths. What do I know about tenths? Or we can even do hundreds. What do you know about hundreds? Can 5 go into a hundreds place? 20 times 20. So 1/5 is equivalent to 20 hundredths. Is that greater than 3300? No. So it must be, I think the answer is 2/5. I need to build it up to, you want to build up to tenths place or the hundreds place? I'm going to build up to the hundreds place. Times 20 times 20. So that's 40 hundredths. And is 40 hundredths between 3,300, greater than 3,300 but less than 5,000? It is. So the answer is 2/5. What am I? 2/5. All right. So each student will be given like bars, like sentence strips almost, like fraction bars. And I'm going to ask you to do in class, can you divide it into thirds? So what do you know about thirds? I cut this and I cut this into thirds. If I had to label this, this would be 1/3 and this would be 2/3 and this would have been 3/3, which is equivalent to 1 whole. What happens if you're given, divide this unit into fourths? So I would fold it, and fold it. I would fold it half and half. Because half of a half, 1/2 times 1/2 is 1/4. So I label this as 1/4. I label this as 2/4, which is really 1/2. I label this as 3/4. And I label this one as 4/4, which is really equivalent to 1 whole. So label the axis and quadrant here. So let's get my text. Well, this is quadrant X. Sorry, this is axis, the x-axis. It's a number line that goes horizontal. This is the y-axis. This is quadrant 1. Remember the C, quadrant 1. So this must be quadrant 2. This must be quadrant 3. And this must be quadrant 4. So the question says, graph, label the axis and quadrant. Done. Graph 7/2, -2. So let's see. This is divided into, let's see, from this is 0 right here. This is 1 whole. So it seemed like if I divide this into 2 parts, this is half, this is half. So half, this would be right here. This would be 1/2. 2 halves, 3 halves, 4 halves, equivalent to 2, 5 halves, 6 halves, equivalent to 3, 7 halves. So 7/2 would go right here. Another way to see is, do you remember from elementary school how to turn a improper fraction into a mixed number? How many groups of 2 go into 7? 3. That's 6. You have 1 left over, so 3 and 1/2. If you do not prefer that way, maybe you rather divide it. You have 7 that's divided into 2 groups. So that's 3. That is a 3. You have 1. How do I get rid of this remainder? Remember, I want to add a 0 without changing the value of 7. So I add a 0.0. Bring down to 0. How many groups of 2 go into 10? 5. So 3 and 1/2 is equivalent to 3.5 or 3 and 5/10, which is equivalent to 7/2. So I know it goes right here. Then it says -2. Is -2 above or below? It's below, so I graph it right here. Next question. It says, graph an ordered pair in quadrant 3. Quadrant 3 is here. So I'm just going to stick one right here and here. Random. What would this one be? Let's see. If these are halves, this would be -1/2, -1, you could say -3/2, or you know what, I'm going to say it as -1 and 1/2, which is between -1 and -2. And then this one is going down, so x-axis. Now let's look at the y-axis. I go down 1/2, go down 1, go down 1.5. So the ordered pair for my point here was -1 and 1/2, comma, -1 and 1/2. What if I had graphed this one right here? This would have been -1/2, -1, -1.5, -2, -2.5. I hate writing these. Comma, oh, forgot my parentheses. And let's see, the y-axis is -2. So -2 and 1/2, comma, -2. Let's look at our next example. Label the axis and quadrants. Let's get my trusty thing. So x-axis, y-axis, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, it says graph -5/3, comma, 1. So let's look at this carefully. Here's 0. Here's 1 whole. If you had to divide this unit, it seems like it's divided into thirds. Thirds. So that's 1/3, 2/3, 3/3. So -5/3. All right, so start 0. On the x-axis, would that be right of 0 or left of 0? Left of 0. -1/3, -2/3, -3/3, which is really -1. negative 4/3, and negative 5/3. So I know it's going to be somewhere right here. So I'm going to put that little thing so I know it's going to be somewhere right here. So that's negative 5/3. Remember, elementary school, so you have negative 5/3. How many groups of 3 go into 5? One whole. You have 2 left over, so it's negative 1 and 2/3. To check your work, I use the popcorn method. 3 times 1, multiply the denominator and the whole number is 3. Add the numerators, 2 is 5, negative 5/3. So it's right here. Then it says 1. Is that going above 0 or below 0? Above 0. So it is right here is the ordered pair. Now graph an ordered pair in quadrant 4. I'll just choose this one. Random one. So let's see. Starting at 0, I go to, on the x-axis, I go to 1. And on the y-axis, what would this be? It's going below, so I know it's negative. It's going thirds. 1/3, 2/3, 3/3, 4/3. So negative 4/3. So 1 comma negative 4/3. Is there another way I could have said that? State that? Let's see. 1/3, 2/3. Negative 1. Negative 1 and 1/3. So 1 comma negative 1 and 1/3, or 1 comma negative 4/3. Label the, here's our next example. Label the axis X, Y, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. List the vertices as ordered pair. Ooh, interesting. Vertices, if you ever heard of that, it means the corner of a polygon. So in this one, the corner is, let's get this one. So here's 0. Let's see, here's 1. From 0 to 1 is 1 unit. It looks like it's divided into fourths. So that means 1/4, 2/4. Is there a better way to say 2/4? Oh, 1/2. So I go over 1/2. So this vertex also would be x-axis. So I go to the right of 0, 1/2. What would the y-axis be? Let's see. 1/4, 2/4, 3/4, 4/4, 5/4. I could have said 1/2 and 1 1/4. Either one would have been okay. What about this one? Let's see. I went over x right half, down 1/4. Down. Oh, negative 1/4. So it's 1/2 comma negative 1/4. Let's look at these vertices. So here's 0. Negative 1/4, negative 2/4, negative 3/4. Oh, negative 1. So I went over negative 1 on the x-axis. What about the y-axis? So here I go down a fourth. A down, that's negative 1/4. So it's negative 1 comma negative 1/4. What about the one in the upper left-hand vertex? Let's see. It's going up, so it's a positive number going up. Positive. 1/4, 2/4, 3/4, 4/4, 5/4. If you think about it, use this vertex to help you answer this vertex. And those are the ordered pairs. So what we've learned today is, again, how to graph an ordered pair. A coordinate plane is broken down into 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. Some graphs are broken into halves. Some graphs are broken into thirds. Some graphs are broken into fourths. So you graph the x-axis. So you go right or left. If you're going right of 0 is positive. Left of 0 is negative. And then secondly, you graph the y-axis. If you're going above, that's positive. If you're going below, it's negative. So this is coordinate plane with rational numbers.